Okay, so we will talk about recursive functions.
Okay.
Recursive. Okay. So recursive means calling a function again and again. Calling a function again and again. Same function you're calling again and again. Okay. So let's say I define a function called, it's like infinite loop you have, right? Just like that, we have infinite function calling. So I define a function called myfunc, okay, 1, and I'm saying print hello. Okay. Now here I go and I call myfunc, right? Okay.
Yes, sir.
Now when I run it, let me run it. Okay. So this is how you call function once, right? And I go here and I call again myfunc1. Right? Now what happens? Myfunc is calling myfunc1. Myfunc1 here, line number 6 is calling the function and it prints hello, and again it calls itself. It goes on calling itself, right? So when you run it, okay, so it has reached the maximum recursion depth. It cannot go on forever. So it has repeated 993 times. Okay, this is called recursion. When you are calling the function, okay, or you can say the function is calling itself. Okay, function is calling itself multiple times. Okay, so I'm talking about a function calling itself, right? So I'm calling this function, and again this for my function 1 is calling it, okay, multiple times. So what is the use of this? Okay, now here you see, okay, this you cannot call for infinite anything, right? Because it uses memory, and at some point your memory is going to be full, so it gives error, right? So it has called multiple times. Now in this case, okay, when you are doing multiple times, you, of course, your intention is not to do it infinite forever, right? There has to be some value or some check, something that will break this function. Okay, there has to be some check which will break this function. Now how do I break this function? Okay, I have to have some kind of counter, right? So let's say I'm passing, I want to do this 10 times. So what I'll do, I will pass 10 here. Now I'm passing this, I need to have a variable that will catch this value.
Yes.
Right? So now this n will gain value 10. Now, okay, now here if I run, this will give error because my func1 is, expecting a positional parameter, right? So here what I can do is I can pass, whatever, right, n, or let's say n. Now again, let's say I want to run it 10 times. So what I'll do here, I'll check if, okay, n, okay, so see, n is 10. Okay, maybe you can do upward counting or downward counting. Let's do upward counting first. I'm saying my func1. If n equal to 1, or let's say 0, I'm going to say, I'm going to return it. I'm going to break. How do you break a function? You break a function using a return, right? So just like how you break a loop, how do you break a loop? You break a loop using
Break statement.
break. You break a loop using break only. Break is the command.
Yes.
Right?
Yes, sir.
So here I'm going to break this using return. So let's say I say return 1 or something, whatever. So when I say return 1, okay, your loop will end and come back to this position, isn't it? Now it's not going to go any further down. Okay, so n is 1. Okay, okay. Now in this case, I'm going from 1 to 10, right? So let's say if n equal to 10, I put, okay, because I'm going upward count, right? So n is 1. Now something has to increase the value of n, isn't it? Now I can put here as n plus 1. Now when I put n plus 1 here, see my function 1. So my func1, n is 1. N is of course not equal to 10. It comes here, prints hello. Then comes down Now n is what? N is 1, so n plus 1 became 2.
2.
So now it goes up again to this, n is 2 now. N is not 0, comes here, prints hello. And now here it becomes 2 plus 1, 3. So when this, my func1 is called again, n becomes 3. So this is how I'm increasing the value of n step by step. I'm increasing the value of n step by step. And after some time, of course, it will reach 10 and then it will say return 1. Now if you run this, so you see,
1, 2, 3,
4. Maybe it could be 9 or 11, doesn't matter. But this is how you can manage. Okay. Now, if you see if it is 11, probably you have to say less than 10, right? Or I mean, maybe less than equal to 9. Or if it is 9, you say 11, right? But the intention is to run this loop multiple times. Run this, not loop, sorry. Run this function multiple times. Okay, same function. I want to run, run same function multiple times. What's the use? Where do we use this? Okay. Now, let's say, open a notepad. Here. Okay, there are some use cases. There are some use cases where you will come in, so you can't use it everywhere, right? So some use cases where, it makes sense to call it again and again, and most common example is finding the factorial. Okay, so factorial. So if you have factorial 5, how do you define factorial 5? How do you define factorial 5?
5 into, yes, exclamation, yes.
Into 2 into 1, right? So if you see, you can say 5 factorial is nothing but, okay, 5 into 4 factorial. You agree? 5 factorial is same as doing 5 into 4 factorial, right? 4 factorial is same as 4 into 3 factorial. Yes? Now see here, whatever logic I write for factorial, okay, so same thing is getting repeated, right? So now let me convert this program into factorial. So let's say I want to find factorial of 5, right? And of course, I need a variable, okay, say result, which will get me the result from the function. And I'm going to print here saying factorial of 5 is result. Okay. Okay. So n is 5 here. Now what happened? So if you see here, okay, two things here. First, when we are calling this function, it has to be n. So when you're passing n, it has to be n into n minus 1 factorial, right? So let's say I call this is a factorial function, okay? So, and this is giving me factorial result, okay? This is a factorial function. This is giving me a factorial function. So, okay, we'll have something here. Okay, we'll have something here which will do the calculation of factorial. Now, when you are returning this, right? When you want to return this has to return what? Return n into n minus 1 factorial. Yes. Right? So see, 5 factorial is 5 into 4 factorial. Yes or no? Okay. Now this has to continue till you find n, because n, when n is equal to 1, okay, then it is not about 1 into 0 factorial, right?
Yeah.
So 1 should return 1 to us. Did you get it? So when I run this, you get factor of 5 is 120. Okay, let's start from beginning. Let me put a paint here. Okay, so I'm calling my func 5. Okay, so line number 2 it comes. My func 5 is here. Now it's checking, is it equal to 1? No, it is not equal to 1. So it comes here, a return. See, return means sending it back to the origin position. But here, return, we are saying return n into, that is 5 into, right? We are saying 5 into. Okay. Now it is calling the function again. So return is waiting for you. Okay. So from here again, we are calling this function. The return will send you back to where you have been called, right? So return, okay. We are calling this first time from here. So return is waiting for it to finish so that it can send it back to you at line number 7. What happened? Here again, I'm calling a function. So here again, I'm calling a function. So it goes up now. And I'm saying n minus 1, 4. It goes here, comes here. It is not equal to 1. It comes here. Now here you have written 4 into again this function. So it goes up again. So you're saying 3 into again this function is called.
Yes, sir.
Again this function is called. So this goes up. Okay. So it is now n 3 into 3 minus 1 2. It goes up 2. It is not equal to 2. Comes here. So it does 2 into again this function is called. Okay, it goes up. Now it is equal to 1. So return 1. So return 1 means, okay, see, this is a function. Return will bring it to the place where the function is called. The function is called from here. So you say 2 into 1. Okay, now when this function is finished running, it will return you 2 here. So it becomes now 2 into 1, 2. Now this function, once it is done, will bring it to you here. So now it is 6, right? Now again, when it is done, it will bring it to here. So it is 624. Now the first iteration, first return, okay, we'll evaluate 24 into 5, which is 120, and bring it down till this point, because this is where first time the function was called. Second time function is called from here, line number 5. So when it is done, it will come to line number 5. Third time again line number 5. So when third function is done, again it will come back to line number 5. Okay. So you will have function inside a function inside a function inside a function inside a function. So innermost function is finished, then second outermost, then the next. Finally, the outermost function is executed and you return back to line number 7. Yes?
Yes, sir.
Yes, now you tell me your doubt.
Previous doubt is cleared, sir. Here in line number 4, written 1 is there, no, sir?
Mm-hmm.
Line
when my factorial of 1 is 1, see, you have to have one ending condition, right? So example,
yes.
for factorial, if you see, factorial example again, if you see, or not here, notepad I use, right? So 4 is 4 into 3 factorial. Then 3 is what?
3 into 2 factorial.
2 factorial, correct?
This explanation all I got it, sir. Yes.
2 factorial is what?
2 into 1 factorial.
Let me finish, then you say you have got it, okay?
Yes, sir.
1 factorial. And what is 1 factorial?
1 into 0 factorial.
1 into 0. It is 1 into 1 only. Or let's say, again, if you want to go to 0, okay. 1 into 0 factorial, okay, fine. Okay, 1 into 0 factorial. What is then 0 factorial will become? 0 into 0, isn't it?
Yes, sir.
0 factorial, if you say, Then 0 into 0, everything will become 0. Then
Zero.
everything will become 0. Because all,
Yes.
all of this, right? So no, 1 factorial is 1 only. 1 factorial is not 1 minus 1 factorial.
Okay.
Okay. So this is where we stop. This is where we stop. So that's where when n equal to 1, I'm saying return 1. I'm not doing calculation of factorial because there's no factorial here. This is the last value. Okay. So
Yes,
1
sir.
factorial is return 1. Everything else is return factorial, calling itself. The 5 factorial function, whatever we have written, 4 factorial will call itself, but now by passing value 4. We have written some logic for calculating factorial, okay, and that logic is repeated multiple times. Of course, you can solve it using normal for loop also, right? Okay, but
Yes,
this
sir.
is more efficient, and if you know this, it makes sense. See, if you see the program, it looks so neat and clean, right? Otherwise, you have to do for loop, if conditions, right? This is simple and short and more efficient in terms of lines of code also, speed also. But it is memory intensive. But it
Yes,
is
sir.
fast. Okay. Now we can have one more such example here. Let's do one more. Okay, and then we move to the next one. So another example is, let's take an example of Fibonacci series number, Fibonacci number. Okay. Now in Fibonacci, what do we do? Okay, your first number is what?
1 and then 1 plus 1, 1 times 1, and then we do 1 times 2, and equal to 2 times 2,
Right.
4 times 4.
So your first number is 0, first term number is 0, second term number is 1. Okay, 0, 1. And third term number, okay, so see, these are like your 1 factorial. You cannot go beyond, there's no logic for this, no formula for this, right? Your first number is 0 and your second number is 1, right? So there is no formula here, right? But now from third number onwards is a formula. So third number is sum of previous two number. So it is 0 plus 1, 1. Okay. Fourth number is sum of previous two numbers. So 1 plus 1, 2. Fifth number is sum of previous two number. 2 plus 1, 3. Sixth number is 3 plus 2, 5. Seventh number is 5 plus 3, 8. So on. So first two number, there's no formula. You have to return the value, just like we did for factorial. Like 1 factorial, we can't use formula. We have to return 1.
Yeah.
Similarly here, when your value is 0 or 1, okay, you have to return, okay, when it is 0, you have to return 0. When it is 1, return 1, right? 0 is the first term, right? It depends, right, from where you want to count. By default, we are counting from 0, right? Counting from 0, 0 is your first term, so it will be 0. First is your first term, first is your second term, so you'll be 1. And rest of the time, you want to recall the recursion function itself. Okay, and here you will have plus, not minus, isn't it? So let's say, coming back here, so okay, coming here, I'm going to define my Fibonacci or something. Fibonacci, something like that. Okay, and okay, now your Fibonacci number, okay, you're passing like n. Okay, so let's say I want to Fibonacci up to 5th term. I want Fibonacci up to 10th term. So n is your number of term that you want to calculate, right? So Fibonacci n. Okay, now here, okay, 0th is your first term. So I'm saying if n equal to 0, then what? Return 0, right? Elif n equal to 1, second term, return 1. Okay, else do what? Else return, tell me.
1 plus or whatever, n plus the number.
N minus, not n plus. Previous to number, right? If n is 0, that means is
Right.
for first term, right? First value. So if you say 1, okay, simple. Okay, if you enter 0, n is 0, simple, you get 0. If you enter n as 1, simple, you get 1. But if you enter n as 2, then we are saying add pivot of 0 plus pivot of 1, isn't it? Return my Fibonacci of n what? Minus 1 plus my Fibonacci n minus 2. Previous to number, n minus 1 is nth. We are trying to find nth value. So nth value is nothing but n minus 1th value plus n minus 2th value. Simple. Now you call this my Fibonacci 5th element, right? So as per our calculation, what should we get? So this is 0, right? If n is 0, I'm checking, isn't it? I'm checking for n equal to 0. So 0 is 0, 1 is 1, 2 will be, I'm not printing it, right? Say value fifth term in Fibonacci series is value, right? Now when you run it, okay, so 0 is 0, 1 is 1, 2 is 1, 3 is 1 plus 1, 2, okay, 4 is 2 plus 1, 3, and fifth term is 2 plus 3 plus 2. You get 5. Yes or no? So we are starting from 0, right? So this is your 0, 1, 2, 3, 4, and 5. Fifth term is, if you pass 6, what should you get? 5 plus 3, 8, right? Okay. So this is how you use recursive function. Function calling itself. You're calling same function again and again. It becomes recursive function.
Sir, now what if we want to say, like, from the user say that okay, we give them a question, choose it.
Yeah, you can give this, right? You can do whatever you want to do here.
No, not like that. Like, I'm saying, like, what if we give the user saying, like, okay, what this do you want? What which
That's what I'm saying. Do whatever logic you want to put here. You say input n equal to input, you get n value, isn't it?
right?
Whatever
Okay.
logic you want to do, you can put it before this, right? Ultimately, you're calling this function itself.
Okay, sir. Yeah.
Right? N equal to int of input. And you pass n here.
Yeah, right, sir. Yeah.
I want to, okay, how will you generate, using same logic, generate up to n number? So n equal to 5. So I want to generate 0, 1, 2, 3, 4, 5. You put this in a loop. You put this in a loop. Right? And you can do print. Instead of n, you pass I, and you print I. Done. Yes, sir. So whatever logic you can put it around this. Main thing is the function, which is calculating the value for you. Okay. Couple of small topics we'll do. One is, how can we do for loop and if else in one single line? Okay. It is possible to perform for loop and if using one single line. Okay. So let's say I have a list of values equal to 3, 6, 9, 3, 6, 9. Okay. I want to perform square of this number, right? So how will I do? I will say for I in range, not range, right? Directly I can use list values, right? For I in list values, okay, y equal to I into I. Correct? Yes or no? And let's say I want to create new list. Pujita is silent. You're there, Pujita?
Yes, sir. Yes, sir.
Square value equal to list. I want to save the value in the list itself. So what I'll say? I will say square val dot append. Right? So now if you print square vals, you should get, okay, because of this input, put this as 5. So, okay, so you got 3 square 9, 6 square 36, 8, 9 square 81, 12 square 144, right? So this entire thing can be done in one line. Okay, how? So I want output to be in a list. So I will say SQ vals, let me put as 2 here, okay, equal to, put a list, because I want output to be a list, I'm putting as a list, okay. Now I want what I'm going to say for I in list val, right? This is the for loop you have mentioned, okay. And since we are getting only one output here, we know this one line here, right? Instead of putting into different line, you can simply say before for what you want to do. I'll say I into I. Okay. And if you print second method is vals. Right? We got same answer, right? So see here, you're using for loop. So this line will not change. Okay, and this is used when you have only one line, okay, one line of instruction. If you have multiple lines, then this will fail. But if you can somehow club, okay, the entire logic into one line, you can simply say output here, I into I. And I want, so it will generate me the values. It will generate 2, 4, I mean, whatever, like, 9, 36, 81, 144. And output, you want it as a single list. So you put it as a list. It gives you a list. I'm not defining an empty list and then appending. Okay. Entire value I'm converting into list and then storing into this. This is beauty of Python, where you can do. See, the purpose, the way Python was designed was to make things easier. Okay. Of course, memory wise, it is not fast comparative to other languages. But ease of use, this is the best language so far. Okay, so this is how you can convert into single line of for loop. Now, let's say we'll do single line of if as well. Okay, if condition can also be done in one single line. Okay, so let's say, let me think of a problem. Okay, so let's take simple one. Okay, where okay, so let's say I put n equal to 5, and I want to check if n less than 0. Okay, I'm saying print. Okay, instead of print, let's say output. I will say. Okay, initially output equal to blank, and now I'm saying, okay, if n less than 0, output equal to negative, right? If n equal to 0, output equal to 0. Okay, and else output equal to positive. Okay, let's say, these are the this is the value that I want to do. Now I want to convert this into one single line. Okay, how will I convert this into one single line? Okay, so just like we did for loop, okay, we can do this also. Okay, so okay, let's say for here, for now, okay, for simplicity, let's do this. Okay, let's have only if and else. Then we'll talk about other things. Okay, so it'll become slow, and then we'll kind of. So see, again, as I told you, right, this is used only when you have only one line here, not multiple lines, right? So what you do is you put this condition. What if n less than 0, okay, if n less than 0, okay, if less than 0, else is what? Positive, okay. So if n less than 0, positive, and if it is, if what should we say? Negative. Okay, negative, and this is equal to your output. That's it. Now you can say print output equal to output. Okay, this is how you can do one line if else. Yes?
Yes, sir.
Let's say you have else if, right? Else if can become little complicated. Okay, so see, else if, okay, so see, if else, okay, if else is not straight away represented as three different things. You have to perform something like this. So, okay, okay, so I was saying that, okay, so if you have to implement something like this, elif, okay, we can only implement if else, okay, but if you want to implement elif, okay, so we have to modify this so as to make it if else. So how do we modify this? We need to modify this as multiple if else. So you say if n, okay, else. In else, you check if n is 0, and then you got it, this logic. So first I'm checking if n is less than 0 or not. Okay, so yes. Else, again you have if else, because else there are two possibilities, right? In else there are two possibilities. So I said if n and this else. So now how to implement this? Okay, So first thing, we will going to copy this part. Okay. Right. So here, if you see, okay, what do we have? If n is less than 0, negative, correct? Then else again you are putting this elif. Okay, so here we are checking n equal to 0, and if this is, then we say 0, and else we say okay, negative. Did you get it?
Yes, sir.
So if else, why is saying negative? Is it negative? Oh no, should be positive, right? Negative is first case. Case is positive. This negative is first case. N less than 0 is negative here.
It's positive.
Right.
Yes. Yes.
So else inside else again you are putting right. So if n is 0, then 0. Otherwise, it is positive. Right. If you go and make this n as 0, you get output as 0. So this is how you can do for loop in one line, if else in one line. All these are possible only if you have one statement that needs to be executed. If you have multiple complex logic, then you cannot do it. Okay, you have to do the traditional way. But if you have just one line, you can use the shortcut.